Solving quadratic equations by factoring. Now, previously we've done factoring when we were dealing with polynomials, and a polynomial is actually, when it's a trinomial, it is actually a quadratic equation. Now, in these first two examples, this is showing that this polynomial or anything has already been previously factored. So these would be our answers. Before, we would have our answers like this, without the zeros. But now we have to get everything set equal to 0. So you cannot solve these equations unless they're set equal to 0. And what you're trying to find is solutions to how many times your graph goes through the x-axis. So when I have, this is my two binomials after I factored, and what I would do is I would set the first one equal to 0 and set the second one equal to 0. So to get x by itself, I would add 3 on both sides. So one of my answers would be x equals 3. So that means at 3, 0, that is where my parabola or my U-shaped graph is intersecting at that point. Now also we have -1 on both sides, so we get x equals -1. So that also means that this is two solutions. So it intersects at 3, 0 and -1, 0 when you draw your U-shaped graph. So it intersects on the x-axis. Now for this one is factored also, and it has this GCF on the outside and then this binomial inside the parentheses. So it already has been previously factored. But because it's set equal to 0, I'm now going to set my GCF equal to 0. And what's left in that binomial that's left in the parentheses. So right now, this is showing me I have two solutions. I have one is x equals 0. That's one of my solutions. I also have, if I add 2 on both sides and I'm trying to get x by itself, I have 5x equals 2. I divide by 5 on both sides, so I have x equals 2/5. So that would be another place that it intersects the x-axis. So I now have two solutions. Now, if you see, this is a trinomial that we've previously have factored before when we were dealing with polynomials. And the difference between when solving by a square root and solving by factoring is that this one has an x squared and an x value. So in this case, I have 3 terms, so I have this trinomial, and now I can factor. I also know that this is my a value, my b value, and my c value, and it always has to be equal to 0. This value in the front cannot be a negative value. If that's the case, then you're going to have to take out a GCF. But right now, this is a 1. And a previous method that we have learned has been the X puzzle, where you put your C value on top, so it would be -22 over -9. So you need what two values multiply to get you -22 and add up to -9. In this case, it's going to be -11 and a +2. So I'm going to write my two binomials. So I have x equals -11 and x plus 2. Now, just like this one, this top one, I'm going to set them equal to 0. So to get my two answers, I'm going to set this one equal to 0 and the second one equal to 0. To get x by itself, I add 11 on both sides, and I'm going to get x equals 11. That's one solution. Now my other solution, if I subtract 2 on both sides, I'm going to get x equals -2. So now this is telling me that this quadratic equation has two solutions. So it intersects the x-axis twice. Now this one again has an a term, a b term, and a c term, and it's set equal to 0. Because this a is greater than or does not equal 1, so it's greater than 1 and does not equal 1, I'm going to actually use the proportion method. The proportion method works where I put my a values here and my c values. So my a values are 2, my c values are -4. So I need two factors that multiply to get me 2, so that would be 2x and 1x. Now I need factors of -4 that if I multiply them together, they're going to add up to this -7. Well, if I put 4 and 1, I know that I get 2 times 4 is 8, and 1 times 1 is 1. Well, I know that this is a negative 4, so I'm going to make it, and this is I have to get negative 7. I'm going to make the 4 actually a negative 4. So now I'm going to write my two binomials. I have 2x plus 1 and x minus 4. And I'm going to set them equal to 0 because I'm trying to solve. So we're solving by the quadratic, these quadratic equations. So I'm going to set this one equal to 0, and I'm going to set this one equal to 0. I'm trying to get x by itself, so I'm going to subtract 1 on both sides. So I have 2x equals a negative 1. I'm going to divide by 2. So one of my solutions, I'm going to put it over here, is negative 1/2. So that means it intersects the x-axis at negative 1/2. I'm also going to solve this one for x. So I'm going to add 4 on both sides, so I get x equals 4. This is my other solution, so this means that this quadratic equation has two solutions. Now, with this one, I'm going to I have this value, and I'm going to make this actually a 3, so I'm going to change that. So I'm looking at this, and I can see, okay, what can I factor out? Well, right now, I can't use either of these methods, and I see that I have something in common between the 3 and the negative 12, and also I have 3 x's here and 1 x here. So when I was looking at this, I'm going to take out a GCF. So my first thing that I'm going to take out is a 3, because that is what's common. So I'm left with x to the third, because 3 times x to the third gives me 3x to the third. And then 3 times what is going to give me negative 12. That's going to be negative 4x. I also noticed I can take out 1x. So I have, this is going to become x squared minus 4. So I'm going to rewrite this as 3x, and it's going to be x squared minus 4 equals 0. Well, this right here is a difference of two perfect squares, so I can make it into 3x, and it's x, because x times x gives me x squared, and then negative 2 and a positive 2, because negative 2 times a positive 2 gives me negative 4. I still want to set all of these equal to 0, so I would set 3x equals 0, x minus 2 equals 0, and x plus 2 equals 0. This one I would divide by 3 on both sides, so I would get x equals 0. That's my first solution. I'm going to add 2 here, and I get x equals 2. That's my second solution. And then I'm going to subtract 2, and I get x equals negative 2. So this equation actually has 3 solutions.